Hello, everybody. My name is Mike Patterson, and welcome to the session on Netflow and Packet Capture, where they complement each other. And for some of you that are really familiar with packet analysis, I think when you see what Netflow offers, hopefully some of you are already familiar with it, that you'll be, some of you are going to be like, wow, that looks like something I can get my hands around, my arms around a little bit easier, because in Netflow there's less detail, which initially might sound great, but obviously it certainly implies that without all the details, you can't always find out everything you need to know, right? On the other hand, the problem with packet analysis is that you've got to have an analyzer there, right? So if the problem is in San Jose to Boston, you're located in Maine, which is where our corporate office is, then you don't have a packet analyzer out there. You got to get one there. So Netflow in and of itself is, by nature, is distributed. So basically, think of it as having every way you have a router, you've got a probe collecting the details. What our company does is we collect Netflow, and we build a reporting tool to look at Netflow, S-Flow. Anybody think of any other flow technologies? J-Flow, sure, from Juniper. Any others? Come on. 3Com, what's 3Com? NetStream, right? And there's the up and coming standard for Netflow. It works for a while. What's that called? IPFix, sure. Yep, IPFix. And so what we do is we basically collect this data, and we're constantly trying to figure out how you want to look at the data. And one of my goals today is to make sure that you understand what Netflow is, the shortcomings of Netflow, and some of the advantages of Netflow versus packet analysis. And then I also want to get in, to some of the reporting, where the technology is going, and then I'm going to wrap it up towards the end. I'm going to be showing you some transfers of files and connections that I made from my PC and captured them both in Netflow and with a packet analyzer, Wireshark, to show you what the differences in the details are. Does that sound good? All right, cool. Well, let's get started. So Netflow is, we're going to cover that. What is it? Developed by Cisco. And then we're going to talk about egress or ingress flows. Who knows what that is? What's that? Come on. I heard it. That's right. In and out. Why the heck would you care? You just want to collect it. Most of the time you don't, but there are some very good reasons why you need to be concerned about if you're collecting Netflow ingress or egress on a router. It's very, very good reasons. Any of you have WAN compression gear, like Riverbed, WAS, then you care about that. It's a big deal. So we're going to compare that, comparison of data exported by the two, what's next in Netflow, where the technology is going. What are we missing from Netflow? What are some of the things that, anyone here collecting Netflow right now? Awesome. Okay, we got almost half a dozen hands that went up. What's missing? You go in there, you look at your Netflow reports, that's right, I don't have that. What are we missing?
Packets, too.
We're missing the packets, but what do you want to know that's in the packets that you wish you could get with Netflow? You can get the protocol, right? We can find out if it's TCP or UDP, ICMP. What? Session information, right? Like maybe you'd like to see that URL information. Maybe you'd like to see the SYN-ACK, right? SYN-ACK, ACK. You want to see all that handshake. You want to see the latency of the connection, right? Can't do it. Well, you can, and that's what we're going to talk about. Some of the stuff that's coming. All right. What is Netflow? We have to cover that. Anyone want to raise your hand and say, I've just never, ever heard of Netflow? Good. These next slides are for you folks. Okay? I'm going to make sure everybody's on. If you think you know what Netflow is, that's right. I'm going to show it in a new way, hopefully keep you entertained, and we'll get through it. And in order to prevent myself from babbling, what I've done is I've scripted some of this that I'm going to be talking about, so I'm going to read it right off my slides. In computer networks today, they host an almost unlimited amount of applications. On wide area connections, you have to have timely answers, right? What end systems or applications are using the most bandwidth? Is the traffic related to business operations? Right? It's Facebook. Yes, of course it's related to what we're doing here at the company. Right? Is it really? Okay? You can't block that stuff. Not necessarily always, anyway. All right. Here's how Netflow works. When host A sends traffic to host B through a router, this causes a flow entry on every router and switch in the path. If host B responds to A, this causes a second flow entry on the router. So now we have 2 flow entries on every router in the path. TCP packets and byte volumes for each flow are counted for 60 seconds. They're summarized and then exported by the router, right off to the Netflow collector. So large Netflow UDP packets, Netflow is big. Large Netflow UDP packets, up to 30 flows in Netflow version 5, up to 24 in Netflow version 9. Each flow can represent thousands of packets. So in this animation, only 2 flows in a single Netflow packet would get exported by the router every 60 seconds. Every flow could represent 1 or thousands of aggregated packets. If connections become inactive, they are timed out in 15 seconds and exported in Netflow. So it's easy to understand that Netflow does an awesome job at aggregating that data down to a single flow. So let's say I set a connection with you, I set a connection with you, and then you start going with that guy, and that guy, and then 2 more across the back. And there are thousands of packets each. All 20 of those flows, up to 30 flows if we're doing Netflow version 5, would be summarized in a single large Netflow packet and sent off to the client. Everybody got that? So obviously we can't have all those details, right? We can't have the entire TCP or UDP payload inside the package for summarizing and aggregating all the data like that. So every switch in the path and router in the path is maintaining a flow cache table of all the flows going through it, and they're exporting all the flows off to the router. So we're getting information about the same flows multiple times. So it's not always necessary to collect Netflow from all the switches and routers on your network, although most consumers want to. Nearly all Cisco-powered networks contain routers which support a technology called Netflow, or a competitive technology such as SFlow, IPFix, or NetStream. Enabling flow technology on each router and switch will cause the device to send a steady stream of low volume traffic back to the Netflow collector. I put a lot of time. A single copy of Scrutinizer can accept thousands of flows per second from hundreds of routers and switches, giving you packet analyzer-like visibility into almost every link on the network. So some of these could be SFlow sending devices. Anyone here collecting SFlow? What do you like? What are some of the advantages or disadvantages? I don't care either one of collecting SFlow versus Netflow.
That's like SFlow is not supported on Netflow is not supported on HP.
Yes, on your HP, right? And that's probably the biggest consumer. The HP is probably the biggest company we deal with outside of Cisco. Very, very popular switches. How many are HP brokers or HP products? Huge. Because people are looking to, they're still buying Cisco routers a lot of times, but they're using HP ProCurve switches or whatever, and they support SFlow. And the difference is with SFlow, you're sampling packets, right? And I got a slide coming up on that, and I'll talk about that briefly. Okay, so I've only got like 1 or 2 slides here, so I'm finishing up on what Netflow is. So we've got to make sure by the time we get through this one that we know what it's all about. Okay. All right. When reporting on Netflow, the traffic sent by A to B is broken out from the traffic sent from B back to A. Right? Makes sense. It is with a packet analyzer too, right? Separate packets. Notice here on the left, host A came in on interface 1, and out interface 3. Host B responded, came in on interface 3, out on interface 1. Everybody got it? Okay, good. So, if you have Freecom Gear, Adtran, Cisco, Terraces, Expand, Juniper, or any of these vendors, they all support Netflow. And this is not all of them. So, everybody in here have gear from at least one of these vendors? Great. Great. So what I'm about to show you and how you can do this is already on the hardware that you have. You just need to turn it on. You need something to collect it with and record on. Our tool's free. There are other great tools out there that record on Netflow that are also free. Okay? So what you'll walk away from here today is a little bit more about the technology and how we record on it. And you can find some of those similar reports in other products. When a technology is not available, a lot of times you can insert probes or put in switches and insert your legacy gear into it. That way we can get Netflow information about all these guys going out here, okay? And there's only 2 vendors that support Netflow on a layer 2 switch. Only 2 vendors. What's one of them? Right. What's the other one? Yeah, who said Terrasis? Good job. All right, cool. Terrasis is the other vendor. So I'm a Cabletron from way back. Worked there for about 6 years. Okay. A lot of times, you know, I think that I may have this slide in here a little bit earlier, but pretty much you're limited in Netflow to source and destination IP address, source and destination port, your TCP flags are logically ended together. These are all the flags that involve the connection. And a lot of times people didn't think, well, you can't get MAC addresses from Netflow, or you can't get VLAN information from Netflow, which you can't get from a packet analyzer a lot of times because that's transparent, right? But you can. You can. Netflow will give you that information, like Nexthop, like your BGP, your autonomous systems and stuff like that. If I have time, I'll cover that. But you can get MAC addresses from Netflow. Okay? But you have to enable it. You have to use something called flexible Netflow. If I have time, I will cover flexible Netflow in this class. SFlow. SFlow is an RFC. It's not a standard. It kills me how the marketing people want to say this SFlow standard. It's an RFC, just like Netflow isn't a standard. Okay? So it's sampling of packets. So in other words, if you have that HP Pro curve and you turned on sampling, then you're going to sample by default like maybe every 1 in 1,000 packets per interface. How often do you sample in your program? Do you have any idea? 500. Sure. So in other words, if you have a low volume switch that you're not seeing, you might crank it up to 1 in every 500 per interface. I've seen customers crank it up to 1 in every 50. I've seen customers try to sample every single packet because they're trying to make their SFlow look like Netflow. It is maintained by a company called Inmon, which makes the chip. It's less expensive for vendors to implement, like on Extreme or Juniper switches, because there's just a chip, and they could buy it and wire it into their hardware. So vendors, here's some of the vendors that support it. And Patterson also has switches that support SFlow, so they do both technologies now, ForceLAN. So, okay. Netflow and bar. Well, this was in my future slides, and I do have some slides coming up showing the reporting, but I just wanted to back up and make sure we understand a few things about the technology. NBAR is, anybody here know what NBAR is? All right, what's NBAR?
It's basically what almost like feedback analysis on the actual hardware itself.
Yep.
They can just say, well, look, you're actually pushing Skype, or you're actually pushing HTTP over 8,000 or something.
Yep, that's exactly right. And what's missing from it? You collected with SNMP?
Run the iOS Jackson, correct?
What's that?
Run the actual 6500.
Okay, so when you bring up your NBAR information, what would you like to see Skype? And then logically, you wonder who is it, right? And you're collecting that Skype information probably, or that NBAR information with SNMP. Right. How do you find out who's doing this Skype?
That's the one back to Netflow, correct?
Yes. Okay, good. That's right. So that's one of the issues with, this NBAR's been around for years. And so you'd be like, well, why is that a big deal? It has nothing to do with Netflow, really. It's something you collect with SNMP. Well, last fall, Cisco decided to start exporting NBAR information using Netflow. Because one of the shortcomings with SNMP is you can see it was Skype, but you didn't know who it was. So now with Netflow, if you upgrade your routers to iOS version 15.1, okay, and you can enable flexible Netflow and get NBAR from your routers, now it's going to, because normally it's going to export the flow and it's going to say, hey, the destination port was 80 and the source port was random number. So what application is it, folks? Sure. Now, does it have to be web browser traffic if it's on port 80? No, it could be Skype. So what NBAR does is it looks at a series of packets and it tries to identify the layer 7 application, right? It tries to say, hey, that's Skype. Oh, that's BitTorrent. That's WebEx. Okay? That's GoToMeeting. That's useful. Right? So that's why we want to enable NBAR. So okay, so I just want to point out this is available as of the fall. You've got to upgrade your routers to iOS 15.1. You have to enable flexible Netflow. This is not Netflow version. It's Netflow version 9 with a twist. And there's information on our website if you want to learn how to enable it. A bit different than ASA, but I'm not going to be talking about that. Okay. Here we go. So now what we have here is we have two primary reports that scrutinize are specific to NBAR. And I'm going to actually demonstrate them in a minute. Applications NBAR, which lists all the top applications by NBAR, and conversations. Traditionally, when we think of Netflow, we want to know the top hosts, right? Whereas when we collect packets, what's the first, after you run your packet capture, and you capture all the packets with Wireshark, what's one of the first things you want to do after you've got to capture the 200,000 packets? Filter. It's like the first thing you want to do, right? Of course. So what Netflow is notorious for, with all vendors that are building a Netflow collector like us, is we're giving you a series of reports like your top applications based on NBAR, your autonomous systems, your top connections, your top hosts, your top hosts with the most flows. Forget about bytes, just a lot of flows, a lot of connections. Okay? Here I've selected a report, application NBAR. Okay? Once I got a list of the applications, you can see on the left that I typed in a filter for Skype. Wireshark, you go up to the very top, and you type in tcp.analysis space flags, or whatever you want to type in for a flag, right? TCP dot ports equals 2787, whatever, right? So after I typed in a filter, then I clicked on the word Skype, right? That host, and I said, give me the top hosts for Skype. And basically, there you go. Now it gave me all the hosts that are communicating with Skype during this time. It's important to point out here that you can't get details from Netflow, like how much Skype there is on the network, and then drilling to see the host from any network analyzer. You have to be exporting NBAR, Netflow NBAR. You have to be exporting that. If you're just doing regular Netflow, you're not going to get this stuff. And I really wanted to kind of bring to the forefront kind of the neat stuff that's available in Netflow today. Otherwise, you're doing traditional Netflow, which is great, but nowhere near as. This is going to get you a lot closer to what you're doing with Wireshark. But still a lot of features missing without getting an actual packet analysis. So let's discuss the templates that are exported by the router. Okay? If you're already exporting traditional Netflow on a router, you need to turn it off before you're exporting Netflow on NBAR. The reason for this is that exporting both can result in duplicate data. So I'm getting 4 templates from my router. Usually when you hear a vendor talk about, just enable Netflow, and you get the information about who's talking through it on all the different interfaces. Well, yeah, that's true, but there's a lot more things you can do with Netflow today. So you can actually tell the router, I want information such as, you want the These are just your traditional Netflow frames, right? And we're giving you all the raw data. This is starting to look a little bit like Wireshark, isn't it? Right? You're already thinking, I want to filter, right? So there's the application ID. That's actually identifying it as Skype or whatever, okay? And then we're not exporting the autonomous system information from BGP, so I don't have that. And then what we're doing is, if you don't have Netflow NBAR turned on, and you're only using traditional Netflow, then we look at the source and destination port in order to make a decision on what app that is. Remember earlier I said, hey, I got source port, random number, 8727 or whatever, and destination port 80, and you all went, well, not everybody, but a lot of people have said, oh, it's HTTP, right? It's browser traffic. So what we do is we look at the source and destination port and we make a decision, hey, we go with a lower number typically, which kind of makes sense. And that's how we identify the app. And then if that's wrong, you can go in and say, no. When you see the 8727, that's actually my database application, specifically if it's with a certain IP address. And you can override that, okay? So the second template that we're going to kick out, if you choose to, is the interface names. Because with most Netflow analyzers out there, including ours, the only way to get the interface names from the router is to export them or to grab them with an SNMP GET using SNMP. The problem is with doing that is sometimes you don't have SNMP access. They'll let Netflow through the router or through the firewall, but they won't let SNMP. There's no other way to get the interface names. So you're looking at your router with 15 interfaces on it, and they say instance 1, instance 2, instance 3, instance 4. And you've got all these great if aliases set up on your routers and switches, and you want to see them when you select them. Okay? So you can do that. That's another template you can kick out. Another template that we're kicking out is the actual NBAR application. We're telling you if it's FastPack or Skype. These are the apps we're actually looking for. Kazaa, H323. So you can begin to understand it's a heck of a lot more interesting to see H323 than it is to see the lowest port, 529 or whatever. So obviously there's benefits to getting the NBAR information. I can also kick out another template from the router using Netflow, which basically gives me counter information. So this is the timestamp, the message total, flows total, the total amount of bytes, processing ID that's not populated, and a system scope. So you can get lots of different templates from the router giving you different information beyond simple who's talking on my network. All right? Okay. If in Scrutinizer, what I'm about to show you is free. So pretty much if you want to collect Netflow, just install our software. It'll drop you data at midnight, or about 3 o'clock in the morning actually. But all of this is pretty much free. There's a few reports you won't get in the free version. Just export it from your routers, install Scrutinizer, and you'll be getting this information. So I went up here and I said, give me a particular report. And then over on the left, I can click on these various hosts and drill in on them for filters. So hopefully you're beginning to understand that with Netflow, although I haven't given you an actual demonstration other than these screen captures, you're beginning to understand that it starts to organize the data quite a bit for you so that you can take a more high-level view before you start entering your filters. Okay? Your top. And the way that's done usually is just top X. Give me my top 5, give me my top 10, my top 25, etc. I could go through all of those different reports and just bore you guys to tears. I think I'd rather get right to the demonstration and show you how they work. Now, is anyone worried here about what enabling Netflow on your router is going to do to the router's performance? We're going to go out there, we're going to turn on Netflow, it's going to capture, it's going to start counting all the packets for each flow, aggregating together all the octets, and exporting them. And so your typical router on a fairly busy network is going to export anywhere between 10 and 100 packets per second. Big packets, right? And I've seen routers on a service provider network export 200 up to 1,000 packets per second. At which point the customer probably ought to consider sampling, but they don't want to sample because they want 100% of the information, right? So when you enable Netflow on your router, typically you're not going to see a performance hit at all. Okay? If it's running on a catalyst switch and it's really busy, then you're probably going to see CPU utilization go up a little bit more. But usually on your router, if you enable Netflow, the CPU is going to be impacted marginally. If you compete with Cisco, you're going to talk about how it's going to hammer the CPU. It's not going to in most cases. There are cases where it will. I did have an old version. I had used, when Cisco first came out with Netflow NVAR, iOS version 15, I jumped on it. We enabled it and started exporting it because I wanted to run the reports. And it drove the CPU through the roof. That's why I said 15.1. You want to make sure you run iOS version 15.1 to export Netflow NVAR. Traditional Netflow worked fine, but Netflow NVAR you need to run iOS 15.1. You can monitor the CPU with traditional SNMP tools until Cisco starts exporting CPU utilization from Netflow, which hasn't happened yet. Any questions so far? All right. Egress or ingress? Most of us are here exporting Netflow version 5, which only supports ingress Netflow. So what that means is traffic going in this interface is collected. Okay? The traffic going out that interface right there is not collected. So you think, that's a drag. I can only see the traffic in one direction. However, if you enable Netflow on all the interfaces, then the traffic that comes in here is collected. And because the flow tells me the destination interface, and I know that it's destined from here to here, I can figure out what traffic is going out this interface by looking at the flows that came in on the other three. You follow me on that? So in Netflow version 5, we need to remember that we're only getting ingress flows, and we need to enable Netflow on all interfaces of the router or switch. Go ahead.
So it's actually taken before or after ACL policies. So if you have outbound ACL on your interfaces, does that have to get on?
That may depend on, I believe it's after the routing took place. So it would have to be with the ACL. I know that's definitely true on the ASA because we get denied flows in the flow exports. Okay, so most Netflow vendors look at where an ingress flow is headed by looking at the destination interface. Using this information, we can determine the outbound utilization on a given interface, as long as, and that's why I put it in caps, you've got to enable Netflow on every interface of the router or switch. When to use egress? Well, right away, go ahead.
How do you know if you're going to sort the results by the amount of data going to each host? How do you know if it's only inbound traffic and not outbound traffic it's reporting? How do you know how much you're sending out to different hosts? Does it make sense?
Ask it again.
If you only know what's or if you only know the data or information of what's coming inbound, how do you know if you're going to sort the results by the amount of data being transferred? How do you sort it like that when you aren't measuring when you aren't getting information from outbound traffic?
We get it in order to, like, let's say you're coming in on interface 1, right? And I'm on interface 2, and I'm sending data back to you. Well, we know because Netflow has collected ingress, I know with the reporting tool, I know exactly how much you're sending to me because you're coming in on an interface. But going out that interface, you don't know because it's not collected going out, it's only collected in. Right? Am I answering your question so far? you have to enable Netflow on the other interface, interface 2, which is the interface that I'm coming in on. And guess what? In the flow is the destination interface, which is where you are. That's how I'm going to do it. That's really, really important because I get these calls into our support. The Netflow tool is understating utilization on this interface. Did you enable Netflow on all the interfaces of the router switch? No. But you have to if you're running Netflow version 5, which is by far the most popular. Go ahead.
So in the case of router-based or ASE, because the tunnel traffic, actually this stuff's obscured. Obviously, it's not the interface per se. So from a tunneling perspective, do you think it's happening on the tunnel?
It's happening, it's getting exported twice. So we're getting it when it came in as a tunnel on port 53 or whatever. And then after it's pulled out of the tunnel, we're reporting on it again.
But you're at least getting both sides.
Yeah. So by default, we ship the product, most vendors do, with a bunch of protocols, IPsec being one of them, ERP and a few others. We just drop them. Because we know it's duplicate data. And besides, you want to see it after it's pulled out of the tunnel. Okay. All right, so in WAN compression environments like Cisco WAS, Riverbed, etc., right, expand, we need to see traffic after it was compressed. So he sent the data to me, right? And then the router routed it, and it went out the interface. Well, guess what? When I report on it, I'm going to use the bytes that he sent me when I report traffic going out this interface. And they were compressed before they went out, so now I'm overstating utilization. Right, with Netflow version 5. You've got to get away from it. You've got to get away with Netflow version 5. There's a big problem. So egress flows are calculated after compression. So what did vendors do like Riverbed? They came out with Netflow version 9, supported egress, and therefore what our customers did is they did a firmware upgrade. Now they can get Netflow version 9 egress, enabled it on all the interfaces, and now when we report egress traffic or traffic going out that WAN interface, it shows it after it's being compressed. Right? Glenn? Good. All right. In multicast environments, ingress multicast flows have a destination interface of 0 because the router doesn't know what interface they're going out until after it processes the datagrams. So I get this multicast that comes in. It's headed for interface 0. Well, you know darn well someone joined that multicast tree, and it went out 1 or 2 different interfaces, right? Well, you cannot figure that out using ingress flows. You have to enable Netflow version 9, and you've got to, that way when the flow goes out, now it will give you the destination interface. Exporting egress flows delivers the destination interface. As a result, multiple flows are exported if the flow is headed for multiple interfaces. So turning on egress when you're multicasting on the network is going to cause more flows, more work for the Netflow collector. When exporting Netflow on any one interface of a router or switch, enabling both on a single interface means that traffic in and out is being exported. So, if this is an internal router or switch, and we enable Netflow, if it's not involved with WAN compression and there's no multicast, just do egress flows. Otherwise, when I send traffic to you, it's going to be collected in. And then when you send back, traffic is coming in, it's getting exported because it went out. And that happens on all interfaces, so you're doubling the amount of Netflow that gets exported. So just because egress has its use doesn't mean you always want to enable egress on your routers. Okay? Stick with egress, and I think you'll be better off. But do enable Netflow. Okay, so now we got a demonstration. Let's bring up the product. Okay, there we go. And I'm going to tell you that this is going to be hard. I'm navigating backwards. So if we're on the East Coast, we're in Maine, so we're, all of our interfaces are underutilized. What happens is they change color based on utilization. And if I click on these, by default, you get your favorite report for the last 5 minutes or the last, your favorite report for the last 5 minutes. And it automatically refreshes every couple of minutes. Now I can come up here and search for exactly the interface that I want. And click on search. Okay? The important thing to remember here is Netflow is about top X, your top N. So because we have routers all over our network, we have probes all over our network collecting packet-like details, not quite all of the detail. And I'm going to get into what that detail is briefly, because right now it's about 2:40, right? How much time do we have left?
3:15.
So we got about a half hour? Okay. So now it tells me over here what version of Netflow or SFlow I'm sending, right? And my pagination over here at the bottom, look at that, I've got 5 pages of top 25 interfaces. And this is automatically rolling up the top. So I'm going to come here, I'm going to select my favorite report, which happens to be, let's say, host-to-host flows. So this will be last 24 hours by default. Now I'm looking at inbound and outbound at the same time, which is why I have traffic on top of the graph and bottom. So I'm going to make it a little bit easier to read. I'm just going to do inbound. And I see some traffic right here that I'm kind of concerned about. And I'm currently looking at the data at 30-minute intervals. What I didn't cover, it's very, very important in Netflow, is let's say you download a big file for me, and it takes 8 minutes. Thousands and thousands of packets. The router is going to summarize what the details about that flow every 60 seconds. And it's going to send a single flow off in one of its many Netflow packets that are going off the point. So if that flow lasts 8 minutes, you have to make sure you set the active timeout on the router to export those flows every 60 seconds. If you don't, then after 8 minutes, you're going to get a flow representing what happened in that flow over the last 8 minutes. And we're just kind of display the data sometimes in 1 minute intervals. And then all of a sudden we'll get to the 8th minute, we'll show this huge spike. And then you call our support saying your tool doesn't work right. You're showing more data in that 1 minute interval than is possible in the line. So we have to make sure we set our active timeout. When we get these, we get all these flows, and we basically assume 1 minute intervals, because that's about the best you can do in Netflow is 1 minute intervals. So you can set, a 1 second active timeout flexible Netflow, but it's kind of ridiculous. So what happens is after 5 minutes, we have to start aggregating these flows together so that we can have 5 minute intervals. And then every half hour, we aggregate 6 of those 5 minute intervals into one 30-minute interval, so we can aggregate this data. So if we look at 24 hours worth of data, or 1 week, if we're looking at 1 week, we get the data in 2-hour intervals or 1 week intervals. If we're looking at 24 hours, we get the data in 30-minute intervals, unless I want to force it right here to 5-minute intervals. And then when I see a spike or something, I say, hey, tell me what's going on in that spike, right? Now it's going to say, well, you selected a time frame where I'll display that data in 5-minute intervals. Everybody see that up there at the top? Right? So now I'm looking at my data, I'm like, hey, that's what I want to look at right here. This lithium canonical thing here. What's up with that? 1 gig, like 20% of my bandwidth used during a time frame. So I'm just going to take my mouse and I'm going to drill in on that just a little bit more. So now we're going to continue in 1 minute intervals. And that pegged the connection. Right? 100%. Now I can force that to bits per second or packets. I can look at my top 400 or whatever. I can look at it in a line graph. A lot of vendors will do pie chart, which I don't find terribly useful. Or you can do the matrix, which I like. What does this remind you of? Anybody seen an interface like this before? Sure. Right. So it's a lot more interesting when you do something like this. That's not anything. Once you get it, though, now I'm going to get it on just about all my reports. So you can see, you get an idea of the volume of unique connections coming into this host or going out to this host, depending on if it's blue or green. Okay. Let's change that back. Now what I'm going to do is I'm going to make multiple connections. So, and this is all free, part of our free version, by the way. Change that back. Check that out again. Okay, so I think what we need to do is we need to start tying this into filtering like we would in R-sharp, right? The narrow in on the top. Okay, so so my options up there, I have my pagination, so I can see all the flows, all the records all the time, right? 100% of the data, if it was on the wire, we have it, okay? Unless we get missequence numbers, and we even collect to tell you if we're dropping any info. Go ahead.
Is this a 100% web-based app?
Yeah, there's no console at all to this. Yeah, it's 100% web-based.
Does it run like one Windows host?
We built it for Windows. Yeah. Okay, so what I want to do is I want to take a look at these. Now I could just click here and say, give me the conversations well-known port. It'll pop up within browser, and it's going to automatically populate the data over here on the left. Now I'm coming over a wireless network all the way over across the country in Maine, so please excuse a little bit of latency here. See how it automatically added it as a filter? So I'd have to type it, or go up to the top and type in IP dot, what is it, SRC equals IP address, right? With Wireshark. Just click on it and add it as a filter. Well, believe me, we're going to get into, as I go through this, what's missing in comparison to Wireshark. So now I'm looking at just this host, either as the source or the destination, which on this interface, it's only the source, right? It's kind of tough. In a single few minutes, you wouldn't be the source coming in on an interface and the source coming out the interface, right? You have to think in terms of that when you're looking at data, because we're giving it to you both ways. But what I'm going to do is I'm going to close this because I want to show you another way to do filter. And I'm going to go back. I guess I can see what's. I'm going to get rid of those DNS names. I'm going to come over here. I'm going to put in a filter. And I'm going to type in host-to-host filter. The IP address that I'm going to put in. Now it could say exclude this data. See how I toggle that to red? But I want to include it. So I toggle back to green, I'm going to add it. Now, there's my data. I've filtered in on it. And this is these two hosts talking. But it is possible, isn't it, that I could be talking to a single host with more than one protocol? Right? I could have an FTP connection going, right? Let's take a look at that. So what I'm going to do is I'm going to take it from host to host, and I want just a little bit more detail. So I'm going to go down to well-known port. So there was only one connection. There's only one. Not the best example. I would have multiples. So it always seems to work much better when I use PowerPoint for everything. All right, so we have one flow or one conversation that's going on between these two hosts. That's it. Well, how many flows was that? So let's go down here and say, give me the flows. There's 3. Okay, because I have 1, 2, 3 minutes that are communicated across, right? And that same flow gets exported 3 times. And the reason they're not aggregating together is apparently the connection was restarted and the destination port changed. Otherwise, it all show up as 1. Okay? And look what else we're getting. Your toss. Right? Now, interesting thing about this, the DSCP, is are you getting that with Wireshark? Are you getting the DSCP value? Right? The QoS tag type of service? Sure you are. Right? Comes in, ingress. Right? You got Wireshark going. It tells you what the DSCP value was set by the host. Right? Is it possible the router will tell you what that could change that? Would the router do that? Would the router do something like that? Sure would. Sure. Why would you do that? Yeah, because you want to prioritize traffic, right? Because you got VoIP on your network. Maybe you set up a diff-serve domain. Sure. So you're prioritizing traffic. So you bet a lot of times the router will change that. Now, if I'm doing ingress Netflow, and I'm only capturing the traffic as it comes in on the interface, right? And this traffic was sent out an interface. I'm only collecting ingress, and I toggle this to outbound right up here, and I say, you know what? Show me the outbound traffic. And the router changed those DSCP values to F or EA or FE or something like that. Am I going to see those changes? The router changed them. Are they going to show up there? Why? Because I only collected ingress right before it was routed. But I would see them if I was reporting on what? Egress flows. So there you go. There's another reason that if you're running diff-serve domain, you want to consider enabling egress flows. But if you enable egress, what's that going to do to the volume of Netflow being exported? And why do we care about the Netflow volume being exported? Why don't we just enable it everywhere? And why do you care? Performance. Your Netflow collector can only handle so many packets per second before it starts to drop flows. So you want to watch that.
What's the average rate? He's talking about
The fastest Netflow analyzers out there collecting the most Netflow is like maybe 40,000 flows per second. We do about maybe half that.
So if you're running a Dell server,
It won't matter. Well, it'll help, but really it's how the software is written and all the pre-processing. We're doing a tremendous amount of pre-processing on what we collect. Therefore, our collection rate's not as high. It definitely will help to have what's most of our customers we're seeing are with a lot of routers, like 50 to 400 routers. We're seeing in the end anywhere from 50 packets per second to maybe 300. If it's a service provider, even if there's only 5 routers, they'll crush ours. They'll crush our application. They'll crush any application out there.
it's based on
It's the amount of, because we got to pull in those very large Netflow packets, and then we have to store them in a database, and it takes time. You just can't move. Sometimes you just can't pedal fast enough. All right, so now I see my flows. You know what I want to see here is maybe I want to see the flow volume between these hosts. This is the amount of flows sent between the two hosts, right, per interval. And it gets particularly interesting because it seems like all too often that we're concerned about, I just deleted that filter, but all too often we're worried about too much traffic filling up the pipe. Too many bytes, right? Well, you can also have excessive flows because you might be worried about a particular host. If I come over here and I say, give me host flows, maybe you're concerned about a host that's not creating a lot of traffic. So the byte volume is not too heavy, but maybe the amount of flows for this short amount of time, which is only 20 minutes or so, but almost 4,000 flows. That could be a problem, so you can set thresholds and stuff like that on it. What I want to point out in this demonstration about using a Netflow analyzer is very similar to Wireshark. You got a filter. Even though we're giving you the top X and we're helping you get the details, you still have to filter. So do we want to filter on a particular autonomous system? Do we want to filter on what the next hop is? Do we want to filter on the protocol, TCP, UDP, ICMP, a combination of the two, and then exclude something based on a TCP flag? You use the filters in combination with the report type to narrow on the data that you want to look at in Netflow. All right, now I better get back to, how are we doing on time? How much time do we have left? 10 minutes?
23.
23. Okay, we're good? All right. I'll show you a couple other things we're doing good. So the other thing you can do, as some of you noticed earlier, is if you see something that you like, then you can come up here and you can email this off to somebody, type in some notes, and get it immediately. You can also save these, save the report, give a name, and that way you can reference it in the future right up here. Those are all your saved reports. Or what you can do is you can come up here and you can schedule it. Oh, I haven't saved the report yet. So you can schedule them so you get them on a routine basis. All right, and then you can even add them to my view. And I'm turning this into a product pitch now. But I also want you to understand that you can pretty much do a lot of these things with any Netflow analyzer. So don't think you're, try to be honest on that.
This is assuming this is
No, this is free. Yeah, what's one of the things you don't get in our free version? What happens? One of the things that happens in a free version.
Data retention.
Right, you drop your data about 3 a.m. every day. There's also, like, you don't get the NVAR reports and a few other things because we're the only vendor that has it. So we got a few reports that we know we're the first vendor to do it, so we don't give them away. Right. But my view is free. Your mapping is free. You can see, you can move these things around. There's your top interfaces, your network volume. And, this is great information. Now, that's something you would pay for right there. What this is you add multiple routers to this particular algorithm. You choose them. And then we'll come back and tell you, hey, let's say it's just your internet router. And we'll tell you, in the last 5 minutes, 345 unique hosts. In the last 30 hours, 7.6 thousand unique hosts. Number of packets, and then you can click on these little trends down here to kind of like some of the stuff that Cache is doing with Wireshark data. Trying to summarize it for you. And so the volume of unique hosts over time, right?
Now this is assuming we were at Netflow statistics from the servers.
Yeah, correct. Yeah. The network maps are alive, so these links actually change color. So if that turns red, it'll tell you it's congested. You click on it, and now it's going to give you whatever you configured the last 5 minutes, 1 minute intervals for your favorite report, which I believe this one is set for conversations. So you might leave that up on. You might leave that up. That map up so you can see it all the time. And then you can have multiple My Views set up. If you're familiar with Network Terminal Sniffer, these are some threats that we're looking for every 5 minutes. We're looking for machines that are scanning the network, DDoS attacks. We're checking the system to make sure you're not running out of hard drive space. The scrutinizer can just fill up a hard drive very fast with Netflow, go through gigs every day. So you can specify how long you want to save your 1-minute intervals, your 5-minute intervals, your half-hour intervals, and you can do that with any Netflow analyzer out there, not just ours. Flows that we saw our SYN, right? And then we never saw our SYN act. So we just saw our SYN. So why would your machine communicate with 100 different hosts in here, all within a 5-minute interval, and just SYN? Sure, SYN flow, right? You're scanning the network. So we're looking for various things, like internet threats. So every hour, this window is something you pay for, because this is more proactive. It's just terrible how often we use Wireshark and these tools for reactive things, even though we want to be proactive. So this is proactive. Internet threats, every hour you're downloading a list of known compromised hosts on the internet. And what we're doing every few minutes is we're looking at all the flows coming in from your routers, and we're looking to see if anyone on your internal network is communicating with one of these known bad guys. And we'll notify you. Okay? So basically a slew of algorithms. And it's not really... What I want to talk about is your top protocols. So right now we're only seeing UDP, TCP, and ICMP. So you can say those are the ones I allow. If IGMP on the network shows up, I want to allow for that. So flow analytics is really something that is not in the free version. And what this window is right here is how long so this algorithm, you only run against one router. But I can click on that and I can specify all the routers I want this algorithm to run against. It tells me how long it takes to run, right? Like less than one second. And it tells me the number of violations in the last 5 minutes. And you can trend that. Because we have to get through all these algorithms in 30 seconds or 300 seconds, because if we don't, then it'll stop and it'll start all over. So we want to make sure that the primary goal of the product is to collect Netflow for reporting. The proactive stuff, looking for threats, if you want it to run, then you have to be careful about how much Netflow you're receiving and pay attention to that so that you don't overrun the system. Because we take a back seat with this stuff versus collecting all the flows on the records all the time. All right. So, back to that. No view. I don't think I have anything else in there. But anyway, the maps. Cameras in there, etc. All right, let's get back to my presentation because I want to make sure I cover today what's coming down the road. All right. That'll come up in just a minute. One of the things that was particularly disturbing to me about the threats, because I know a lot of these classes that we're attending here are about watching for certain threats on your network and looking for constantly monitoring for issues. And this gentleman that I met in Rochester, New York, about a month ago was telling me that his company is hired to break into companies electronically. So, for instance, he'll find out who the plumber is, have shirts embroidered, rent a van, sticker it up, show up, watch the employees going in the door. Big company, it's a lot easier. Just walk in the door, act like the printer repairman or whatever, and basically get on the network and wreak havoc. So we got hired by this bank. And what the bank wanted to do is basically to find out how easily their online e-commerce type system is compromised. So imagine someone coming to your town and they decide, well, they want to target you or someone else, because everyone's looking for odd traffic patterns, right? So what he would do is he would basically create a Facebook page, find out, wherever your high school was, and find out someone in your graduating class that maybe is participating in Facebook. And so he'd create an account, assume their identity. And then he says, oh, hey, so-and-so, I'm your friend, you know this person, and you check the filters are all legitimate, because he put some pictures up there with it. It wouldn't be too hard to get that stuff. And then he assumes that person's identity. And then, 40 or 50 people that are in that town obviously join his Facebook. Right? So now he gets your email addresses, he knows who you all are. You ask him questions, he answers them very generically, because he really doesn't have a clue about this person, right? Other than maybe where they work, etc. And then, because the bank in town is fairly good size, well then, what he does after he has your email addresses, he builds a domain. And let's say the bank is American Bank, let's say. So he would just buy a domain called dumbwebsite.com, and then create a subdomain, americanbank.dumbwebsite.com. And then he has all your email addresses, so he create this website that looks identical to American Bank. Identical. Then he sends you an email from that account saying, hey, we're testing our e-commerce site. It's not ready for production yet, but we're wondering if you could just log in and test it for us and let us know if you have any issues. Right? So you hit the URL. Right? They got your email address, the one you don't give out. You hit it. You log in. Work fine. Says, oh, thanks, it works fine. If you have any issues, report back to this address. Nobody ever does because everyone logs in. Well, what do they now have? Login and password. So now I can go to the bank's website and log in with your login and password if you were fool enough to click on that. And all the traffic looks completely legitimate. So I just think that there's not enough awareness for that particular type of threat. I think it's just really scary. All right, so let's go through this. Okay, so my first example of comparing Netflow to Wireshark. I FTP'd a file. I started Wireshark, I FTP'd the file, I logged out, I stopped Wireshark. I got 6 flows representing 2,221 packets. I got 6 egress flows representing 1,123. So let's go look at it. Egress first. So I looked at the, I clicked here to view raw flows, which I didn't show you today. Here's all my flows. This FTP can be kind of chatty with some multiple connections initially. I got 6 flows, various packet counts. Here's the big one when I transferred the file, right? And it totals, if you add that up, to 2,221 packets. But you don't get a lot of details. If I go into Wireshark, and I'm looking at the data, I have to, I'm not going to be able to see that flow, like the fact that there were 6 different flows, maybe you don't care. I get my 2,221 packets down here, but I get a lot more detail. And I don't get a trend or anything like that. So you're beginning to see the difference between Netflow and Packet Analyzer. Okay? Well, let's go take a look at the other direction, egress. So, egress, I got 6 flows again, communicating back, of course. Total of 1,123 packets. Okay, with the source and destination, source address, right? Then what I did is I went into Wireshark and I saw my 1,123 packets going in the opposite direction. Let's dig into this just a little bit deeper, though. That was pretty basic. Let's look at the capture details. With Wireshark, I can drill in and I can see my TCP flags, because if it was obviously a SYN initially, right, and Netflow is going to AND those together, I can get the password that I use to log in, I can get everything. You're just not going to get those details with Netflow. With Netflow, here's all the details you get. It's a little overwhelming at first, but let's just go through them quickly. We see up here we get the flow direction, it was captured egress, the application ID, right? It's FTP. No BGP information because we're not exporting it from the router. The common port, right, which is the lower of the two ports. Destination address, the prefix which wasn't populated. Destination port, right, the app, hitting the FTP server. The egress interface, it went out to T1. The flow class and the sampler are not being used because we're not sampling. The beginning and ending of the flow, okay, which most vendors aren't using. Because when you look at a Netflow analyzer, most of them out there, they're showing what they want you to see. They're not showing you everything that comes into Netflow. This is everything. We're not even showing you this, right? You get this only if you go to FlowView. The IP class of service, right? Which, if you want to see if it changed or not by the router, you have to be enabling what? Egress flows, right? The next hop that it's using. Okay, that's just a repeat of my screen capture. The octet delta count, representing 3 packets when that occurred. It was TCP, not UDP. The source address that it came from. The source IP prefix length. The port, random port, and all of your flags are ANDed together. So, because normally with Wireshark you get SYN, right? And you get SYN-ACK, and you get ACK. That would be 3 packets. And what this thing is doing is just, like, you sent packets with all of these, so right together even to when it was finished. And if there was a push, that would be in there too. Okay? So you're not getting that detailed breakdown that you like with Wireshark. So Netflow is not packet analysis. You do not get the details. I don't think you ever really are. And even in Netflow, when you can export the entire packet, you're going to use Wireshark to decode it. Because we don't want to build a decoder, right? Why? We need Wireshark. All right. So what about flags? With Wireshark, we get multiple packets. With us, we're just going to. The router's just going to logically AND them together. You're going to get them all at once. So you're not going to get all that detail. So I went to LLbean and did the same thing. I captured the packets. Got 2 flows representing 11 packets. I'm going to go right by this because I think I'm running. How much time do I have left, guys?
7 minutes.
7 minutes. All right. I went into Wireshark. There's my 11 or 12 or 13 packets in this case from LLbean. I can dig in. I can get all of the details, right, that are inside there. The actual URL of the page, which you're not going to get with Netflow today. Okay? But you are going to get the URL. More and more details coming available in Netflow. So I did a VoIP connection, and with Wireshark, I'm going to show 1364 packets. With Netflow, I get 1 flow. Right? Same with the. What I did is I made a call. The other end picked up. I hung up. That's all I did. Right? They picked up. I got the answer machine. I hung up. My computer to the PBX. I saw all the packets, and then when I went to look at the Netflow, there was only 1 flow, representing thousands of packets. So you get an appreciation that all these packets, you're not getting the detail, but it's been scrunched down, so you're not getting all the detail. PBX to my computer again, and 1 flow in return. Okay. Distributed collectors. What if your network is huge and you need to collect Netflow from, you're just overwhelming the collector? And typically what you'll do is you'll have multiple collectors for Netflow, and then have an interface where you can see all your different servers in a single interface. And that's how we address that issue. Detecting malware, I talked about that earlier. And basically these are looking for anyone that BitTorrent on your network, people sending out, trying to make connections to IP address, and the router sending back ICMP destination unreachable. We can alarm for that if you get too many. Various algorithms start turning into a sales pitch, so let's skip over that. Future of Netflow, what are we seeing? Well, what did I tell you earlier was missing from Netflow? They're getting a packet analysis. It's that latency information. So we're starting to get it. So we're looking at a particular probe here. I filled it in, a user calls up and says, it's so slow. right? Okay, it's slow. What does that mean? So I filtered. I set a filter for source and destination address. I viewed one of our standard reports, but guess what? Remember, as a Netflow vendor, we only show you what we want you to see. Well, I need to see all the fields that the tool doesn't support yet. So I launched FlowView, and I actually saw that latency. I got the application latency, I got the client delay, depending on where you put the probe on your network, as well as the server latency. So we are seeing latency. This is something called mProbe, right, from Luca Deri in Italy. So latency is, that's some beta code, but that'll be available later this summer. The other thing, just more examples of getting that type of information. Also seeing not only the client latency, server latency, application latency. The way it calculates the latency is exactly the way the gentleman pointed out in his class this morning by looking at the TCP flags, right, for the setup, the SYN, SYNAC. And so we're getting the latency. If you put the agent on a server or you just use it as a probe, we'll also give you the URL information. Then you can click on it and actually see the exact URL. Now, if you're exporting the URL information, that's going to cause more flows. But you are getting URL information from the nProbe, and I can tell you from the vendors that we're working with out there, the hardware vendors, firewall vendors, etc., you are going to see URLs and latency exported by more and more hardware vendors supporting Netflow. Here's one of our riverbed customers was telling me that apparently sometimes the appliances are, he wants to buy the right size so he doesn't spend too much money. And so we built this report so that he could go in and basically, like I said, a lot of people are concerned about too much traffic in terms of bytes, but they price these WAN optimizers apparently sometimes based on, depending on the vendor, flow volume per 5-minute interval or 1 minute or one minute interval. So we were able to tell them at any given time, this is the volume of flows that you have on your network. And that helped him buy the right hardware. This is a tool that I hope to talk to Gerald about. Gerald in here? So what Gerald did is developed the founder of Wireshark. He built a IP fix agent that goes on a server, and it tells me what processes are running on it. So therefore, I can monitor those with Netflow. It really has nothing to do with traffic. It has everything to do with monitoring the server and the vitals of that server, which I think is pretty cool. It needs a little bit more development, but we were experimenting with it and exporting it to our tool. Pretty neat stuff. So what's next for Netflow? We are seeing packet capture. The first round that they did with it, we worked very closely with Cisco. It'll capture all TCP or UDP and just hammer the network, hammer the CPU of the router. Not implemented well because you can't implement filters yet, but you will see it. And we'll be looking at the traffic when we get the actual packets using Wireshark, not a Netflow analysis tool like us. Doesn't make sense. We're seeing sample flows now like SFlow. We're seeing IPv6 is already here. We're already supporting IPv6 if you're playing with that. Syslogs, like for the Cisco. How many people here have a Cisco ASA? So the ASA is very unique. It exports what's called bidirectional flows. And they're also exporting when that flow is denied. So the flow comes in, it's allowed initially, then it figures out what you're doing and it denies it. And those denied flows are kicked out. They're basically syslogs and they're kicked out in Netflow. So what you're seeing is now you're seeing your Netflow reporting tools start to become syslog reporting tools. The caveat to that being exporting syslogs with Netflow is a lot more efficient because you can stick up to like 17 messages in a single Netflow packet versus if you've ever turned debug on your firewall, it'll just hammer the collector. So it's a lot more efficient. Cisco's realizing and they're spending more money trying to do more stuff with Netflow. interesting thing about the ASA is called bidirectional flows. What that means is when I make a connection to you, okay, since I initiated the connection, and because I'm downloading a file, you send me this huge file. So even though I started it, you really look like the troublemaker because you're the one who filled the pipe even though I asked for it. Well, what Cisco does on the ASA is they do these bidirectional flows where they'll put, because I started the flow, they put the bytes that you sent me on my flow. So it'll look like I actually created the traffic. Which, when you're looking at inbound utilization on that link, it overstates like a son of a gun. So you got to realize that Cisco's doing some funky things right now with the ASA with bidirectional flows. So in summary, today I wanted to talk about the differences between ingress and egress Netflow. What's one of the give me 2 reasons why you want to enable egress. 2 reasons why you want to enable egress. Why would you do it?
Validation of quality service.
Quality of service, right? The DSCP values are changing. Why else would you do it?
Compressed links.
What's that?
Compressed links.
Compressed links, right? If you're Riverbed or WAS. We talked about advanced filtering and how you basically use your filters to include or exclude the data you want to look at, and then changing the report type. We talked about how well to leverage reports, the differences between Netflow and packet capture. Are we starting to understand the differences between Netflow and packet capture? Get a lot more detail with packet analysis, so we're not going to see much more merging, I think, of the 2 technologies. Pretty much going to stay separate, because to do packet capture with Netflow really defeats the purpose of the technology itself. And then we also talked about where the technology is going. What are 2 things that we're going to start seeing from Netflow, probably in the next year from companies that I really shouldn't name? Latency. What else? Latency. What else are we going to start seeing from Netflow? URLs. That's exactly right. So thank you very much, everybody. I'm Mike Patterson. I'm with Plixer International, and I appreciate you attending this class. Any questions?